through hundreds of different fire protection responsibility areas, right? Hundreds. How are you going to know at which particular point you have the leak in the first place? And then once you figure out you have a leak, you have to figure out, well, who do we call? What's the right agency? Right? These are not trivial or easy questions. Likewise, you're the local emergency services. You've got a leak or a release. You know, now it's 3 in the morning. Okay, I've got I'm sitting here looking at a puddle of oil. Well, now's not the time for the head scratch. Well, geez, you know, who's our pipeline operator? Which one was it? Can we get their number? Does anybody have a phone book? You know, how do you spell it? Not what you want to be doing. Is there an immediate life or property threat? Right? This is going to be critical from an incident management standpoint. It also may bear on the decision-making of the pipeline operator in terms of they need to know as much as they can, as quickly as they can, to mobilize the proper resources. What specialized resources are needed, and how do we get them? Right? We're dealing with this in New York. Right? How do we mitigate oil spills on water? Right? Not from pipelines, although that's an ever-present concern, but oil by rail. Right? We have oil by rail in New York. It comes right down the Hudson River, right, along the bank. So if you have a release, some kind of a derailment, you could very well get a significant oil event onto a navigable waterway. Who's going to deal with that? Right? Local volunteer fire department, they might have a boat. Do they have booms? Do they have the appropriate equipment? Do they have the training? All those issues. And then should we shut down the pipeline? Again, pipelines are under the control of pipeline operators, not emergency services, right? We can point and we can shout, but we don't shut down pipelines, right? The pipeline operators shut down pipelines. They know how to do it. We need to give them information in order to help them reach the appropriate decisions in that area. Do we start an evacuation or public protective action? And will state or federal resources be required? So these were the big ones. It's not all of them, but these were common to pipeline incidents. So I'll walk you through this real quickly. Actually, I'll jump ahead. So what we did, or what you do here, is we basically developed a number of essentially decision trees. And so if you look at the top here, we say that this is the role of first arriving responder. And we start at the top and we move down. And so what we do is we say, what are the objectives? And we get those by talking to the emergency responder, right? So and we'll go into more detail on the how, but basically determine the nature of the emergency, okay? What are the early things we have to do? That's an objective. There's a concrete decision that's associated with that objective. In this case, is this a pipeline emergency, right? And so once you have that decision, how do you make that decision? What are the sources of information that you need in order to make that decision? And that's what's on the bottom row, right? And so that would include some or all these. It may include information from witnesses, right? It could be physical damage, right? Is there a backhoe sitting in the middle of a big hole in the ground and there's a terrible natural gas odor? That's probably a good clue. First-hand observations. Is law enforcement, are people there able to, you roll up on the scene, yeah, okay, we smell something. Do we see plumes? Do we see people laying out on the ground? Not an issue with oil and natural gas, but with ammonia certainly. Behaviors and injuries to affected people, and then dispatch information and procedures. So all those collectively are used to help make the determination of, is this a pipeline incident? Is that clear? We'll do another one. So how do we do this? Well, it's the beauty of this. This was a technique that Professor Groner adapted from basically usability analysis for software design. And it basically looks at as we said, getting decisions and asking a series of very naive questions in a structured way in order to gather the information we need. And so you assign, the key thing is you assign a facilitator and a note taker, two different people. The facilitator, we found in our experience, is it's best not to have an experienced expert as the facilitator, because they sit down with the person that they're interviewing and they immediately jump into jargon, and they're grunting and they're making signs with each other, and it's all nonverbal, and then it's over in 5 seconds and nobody knows what was really supposed to happen. And so you basically you get your key response personnel. These would be people who typically be in a command role at the initial stages of an incident, right? So you start questioning them, and you basically make a table, much as we had there. We actually do it with an Excel spreadsheet on a projector. The note taker types in information as they say it. So you say to the battalion chief, "Okay, battalion chief, what do you want to, what do you do at a potential pipeline incident? How are you going to know if you have a pipeline incident?" Well, they'll go through those things. All said, well, I'll look, I'll listen, I'll see, right? So then you fill in. And you add those things. The participant sees that. They agree on it. There's nothing secret about it. And if you have multiple responders from the same discipline, they reach consensus on that, and then you move on to the next one. And so, as we said, ask them about the decisions they need to make, information needed to make that decision, where they would get that information. Now that gets into the information flow piece. Information flow, right? If you are, how is an emergency responder, how's a pipeline operator going to get information from a witness who's on the scene of an incident? Right? Are they going to get it firsthand? Are they going to get it second or third hand through public safety dispatch? Are they going to call a toll-free number direct to the pipeline operator? Well, indeed they might. If they are living close to the right-of-way, they see the sign out there, they've seen it for 20 years, they may call the pipeline operator. They might not, though, right? And so it's important that if that goes to the public safety dispatch, that information gets passed along. Is it going to come by radio? Is it going to come through data? Is it going to come through a phone call, right? All those things. And then the other piece here is, when does a decision need to get made, right? Some information is needed at a certain point in time, and if it doesn't come at that time, you make the best decision you have, or you may not make a decision, right? And so certain information, many times, it would arrive too late at the large loss incidents, and so you need to think about this in advance and make sure that you have the means in place to communicate information back and forth between those critical parties in a timely fashion. And so what you can get from this is pretty powerful, in that you can take a group of diverse responders, and we did this with pipeline operators and everything else. I'll never forget it. We sat down, and everybody thinks, we all knew as academics this was the right thing to do, and there's going to be all kinds of areas of miscommunication. We're going to help flesh these out. The first thing we did, we had a distribution pipeline, natural gas pipeline operator in the room with emergency responders. And so the first thing we did is we started throwing out the term first responder. And then what happened? Well, the natural gas pipeline operator used the term first responder internally, and they referred to their employees as first responders, right? So it was marvelous, because immediately we hadn't even gotten off the starting blocks, and we had confusing terminology between two groups of parties who work hand in hand on an everyday basis dealing with usually moderate or low consequence incidents. So what this can do is it can allow you to take a diverse audience, and we did it with emergency responders, environmental people, pipeline operators, and emergency managers, and get them all to basically spell out what they need to know, when they need to know it. And then the local question is, how are you going to get that information from point A to point B? So essentially, the process we just went through for the fire service, we repeat that with the other groups. You don't want the groups to be too large. If you're going to go through all this, then we'll give you the way out here in a couple of bullet points. But you don't want many more than 10 people. You don't want more than 2 or 3 disciplines. We tried this in a big panel. We had everybody in the same room. It was a disaster. No pun intended. So at least a tabletop disaster, because you couldn't manage everybody. And so you don't need, you deconflict this after you get each discipline's information down. Then you merge those information flows, you come up with these tables, and then you send them back to the participants, and you verify, is this right? Have we got it? And everybody says yes, and we're ready to move to the next stage. You don't have to go through all this. It's nice if you do. we're working on a video to help talk people through doing it, but it's not that complicated. But the tables that are in your guide basically show the output from the work that we did, which again is generalized across the U.S. and generalized across those roles. So I would speculate, I have pretty high confidence that it's applicable here in Canada as is. And so what that does is it allows you to jump through the initial process of what do you need to know, what do you look at, because we're all hopefully managing incidents in a pretty similar fashion, and jump right to the information flow component, which is how are we going to find this out? How am I going to get the fact that, you know, there's hissing to the pipeline operator? How am I going to get to the initial responder the fact that the pipeline, you know, company is en route and will be there in 15 minutes? Those kinds of questions. So there are a number of findings from the project, and this is by way of wrap up and to reinforce some things, some of which we didn't really talk about, but again, we're distilling it was about a 2-year research project into a 90-minute talk, so there's a lot in the report. A number of factors that are important to bear in mind as you're looking at these incidents or thinking and planning for incidents. And again, excavation and understanding excavation is a component of pipelines integrity management and safety programs. Excuse me. But you know, just anybody can get behind the controls on a backhoe, and so you're always going to have a knucklehead out there, and the knucklehead factor is alive and well. I don't know if that's the Canadian term for knucklehead, but there's plenty of them, right? And they're always going to be out there doing stuff, and so that's always going to be a concern. As we talked about, proximity of pipelines, particularly gas pipelines, to electrical equipment. As we saw down in, if you look at those pipeline maps, in many cases you have multiple pipelines with multiple products, with multiple operators in the same right-of-way. So you've got a big puddle. Well, there's 3 pipelines here. So how do we know? We don't. You got to know to call all 3, right? Proximity of people to pipelines. If you look at San Bruno, you know, do we have houses? Do we have development right on top of them or directly adjacent to the right-of-way? And there's a group that looks at this in the U.S. in terms of looking at land use controls and some of those concerns. And they have some pictures that are frankly a little harrowing in terms of how close properties have been developed next to transmission lines. But obviously a concern. If we're in a rural area, you know, versus in an urbanized area, you've got different level of severity. Technological failures or misuse of technology. SCADA systems may be prone to give alarm conditions when they're not always the case. And you have delayed or inadequate notification is the most common problem, and it has the greatest consequences. So if nothing else, this reinforces the need to plan for this in advance so that when a potential incident comes up, those communication paths are identified, the information flows right away. Pipeline incidents are very complicated incidents, right? These are the kinds of incidents that ICS, Incident Command System, was built for, right? And they are complicated from the word go, right? You have multiple agencies that have to respond. You have the potential for large loss. You have novel loss in terms of environmental damage that you don't deal with on an everyday basis. They may involve a federal or provincial response on the initial stages. There's an absolute need for rapid, accurate information exchange, okay, and that's not an easy thing. It may involve evacuations or sheltering in place of significant populations, depending on the product involved and the nature of the incident. And you need to communicate with the public and coordinate multiple disciplines at the initial stages of the incident, right? So this is not, you know, fire department, fire services don't own pipeline problems. Pipeline operators don't own pipeline problems. You know, law enforcement doesn't own pipeline problems. Environmental agencies don't own pipeline problems. You all have to own them collectively and work together in order to mitigate them effectively. So this is just a highlight from the report. There's a series of these. This is the kind of the final stage of the information flow. analysis. This one happens to be for the pipeline operator, and so you'll see there's columns there for information.